Hello, I am Peter G, and today we're going to discuss the k-nearest neighbor, or KNN, so without further ado, let's start. What is k-nearest neighbor? K-nearest neighbor is a type of supervised learning algorithm used for both regression and classification. KNN tries to predict the correct class for the test data by calculating the distance between the test data and all the training points, then select the k number of points which is closet to the test data. To further understand the KNN, we have an example here. Suppose we have height, weight, and t-shirt size of some customers, and we need to predict the t-shirt size of a new customer given only height and weight information we have. Data including height, weight, and t-shirt size information. Peter G, how can we predict the size of the t-shirt when the data given is only the height and the weight? Well, that's a good question. Here, we can calculate similarity based on distance function. There are many distance functions, but Euclidean is the most commonly used measure. It is mainly used when data is continuous. Manhattan distance is also very common for continuous variables. Suppose we have a new customer named Monica, has height 161 centimeters and weight 61 kilograms. Euclidean distance between first observation and new observation, Monica, is as follows: SSQRT 161 158, 2 positive 61 58 squared. To further understand this, we have a table here. Find k nearest neighbors. Let k be 5. Then the algorithm searches for the 5 customers closest to Monica, that is most similar to Monica in terms of attributes, and see what categories those 5 customers were in. If 4 of them had medium t-shirt sizes and 1 had large t-shirt size, then your best guess for Monica is medium t-shirt. Here is our k nearest neighbor visual representation. So we have here our graph, and this one here is the new data that we will be predeciding. Based on this graph, binary dependent variable, t-shirt size, is displayed in circle and box shape. Medium t-shirt size is in circle shape and large t-shirt size in box shape. New customer information is exhibited in hexagon. 4 circle highlighted data points and 1 box highlighted data point are close to hexagon. So the prediction for the new case is circle highlighted data point, which is medium t-shirt size. The KNN also have a pros and cons. This is the pros of k nearest neighbor. It is easy to understand. It has no assumptions about data. It can be applied to both classification and regression. Lastly, it works easily on multi-class problems. Its cons is it's memory intensive, computationally expensive. The KNN is also sensitive to scale of data. It does not work well on rare event, skewed target variable. Lastly, it struggles when high number of independent variables. And that's all for today's discussion. I hope you've learned a lot about the topic I have discussed, which is the k nearest neighbor, or the KNN. Thank you.